last 10 minutes. I'm going to talk about test functions and distributions. Test functions and distributions, okay? Now, we're dealing already with functions that are discontinuous derivatives. We're also dealing with singular functions, right? Or we'll call them distributions, right? And so we want to introduce what are called test functions in order to better define how these generalized functions work, okay? Okay. And let's say phi is a test function, okay? And it needs to be compactly supported, and it'll be C infinity, okay? C infinity with compact support, okay? A sequence phi n, okay, converges to phi in this space of test functions, okay, if the following things are true, okay. If the support of phi n is a subset of K, and the support of phi is a subset of K, for K, a subset of R, closed and bounded, okay? And second of all, the jth derivative of phi n converges to the jth derivative of phi. That's what those are. As n goes to infinity uniformly on K. All right. So essentially, J equals 0, 1, 2, 3, so on and so on. So basically all derivatives. All right. Another way of saying that is that the supremum of x and k of phi n j of x minus phi j of x goes to 0 as n goes to infinity. Okay, so that's test functions, right? What about distributions? Okay, distribution f, we'll call it, acts on a test function. You need to know how it acts on a test function. Phi to produce a number f of phi, right? So this is important, right? Because this is a little bit different than f being a function, even though we sometimes cavalierly call a delta function, right? So f maps D to R, okay? And it has the following properties, right? First of all, f of A phi 1 plus B phi 2 equals A f of phi 1 plus B f of phi 2, right? Where here A and B are reals and phi 1 and phi 2, well, these are test functions, right? So we should have linearity, okay? The second thing is that phi n converging to phi in D should imply what? Well, it implies f of phi n converges to f of phi, okay? So we have continuity of distributions, right? Not continuity in the sense that you're probably thinking of with respect to functions, but we have this continuity property with respect to distributions, right? Great. So then, you may also denote f of phi, okay, by just something like this. This isn't quite the inner product, but f acting on phi, okay? And we note the space, call it D prime, of distributions is the dual of D, okay? And some functionals are nonlinear, okay? And thus not distributions, okay? So just because you have something that acts on a test function, right, doesn't mean it's a distribution, right? This is not a distribution here, okay? It's not linear. Okay, let's do just a couple examples and then maybe out of time, okay? So some examples of distributions, okay? So let's take phi living in D, and one possible distribution is just the integral, right, of a test function, right? So you don't necessarily need to have it be something that has these peculiar kind of measure zero properties like the delta distribution does, okay? You could also have a distribution where you just integrate the test function from 0 to infinity, okay? See if you can think of what distribution this would be, right? This is the heavy side distribution, right? Because you're basically cutting off everything below 0 when you do the integral. Another distribution, which is probably one that's used very often, right, is the delta distribution. Another example would be phi prime of 0, which is sort of like a derivative of the delta distribution, okay? Okay, so maybe try and show on your own these are linear and continuous, okay? Can't remember. I may have assigned that as a homework problem, okay? One thing that's important is you should not confuse the generalized function with the distribution, okay? So a Heaviside function, right? You think of that as a step function. That's not the same as the Heaviside distribution, right? Because the Heaviside distribution is the whole integral operator that's going to return a number in this case, right? That's a functional in this case. All right. So a couple of things, right? Example 1 is associated with generalized functional, or function, sorry, just 1, right? So it's not integrable, okay? And then as we set up here, right, 2 is associated with f tilde 2 of x is equal to h of x. Just a piecewise continuous function there. Okay. So those are some examples of distributions. I think that's probably enough for now. Next lecture, which will be Wednesday of next week, we'll talk about some properties of distributions, okay? And then we'll move on to the more general framework for computing Green's functions. And then probably the Monday of the week after that, we'll start on method of images. But I think by Friday, we should have basically all you need to start on your homework. You can certainly start on your homework now by doing the chapter 8 problems. And I would encourage you to, well, once the exam's over, go ahead and read chapter 9 and try and get started on the chapter 9 problems. Okay. That's a good place to stop for today. Thanks a lot. I'll see you on Friday.